Alright, in this section, this is going to be section 6.2, and today we're going to learn about the law of sines. This is going to be part A of this video, so we're going to do the simpler ones today, and then on Monday when we're actually together live, then we will look at the ambiguous cases, which are a little bit more difficult. So, trig, we know we can use whenever we have a right triangle. However, there are lots and lots and lots of triangles that we encounter every day that are not right triangles. So, it would be helpful if we had some formulas that we could use for triangles that are not right triangles, and we do. So the one we're going to focus on today is the law of sines. And so first thing I'm going to do is I'm going to just draw a triangle here that is not a right triangle, and I'm just going to label it capital A, capital B, capital C. And I want to point out something here. Notice that I'm labeling these vertices with capital letters. So that's how we label our vertices. And then if I want to label the lengths of the sides, I have a capital A right here, so I'm going to label the side across from the capital A lowercase a. So we use those lowercase letters for the lengths of the sides. So lowercase b would be across from angle B, and lowercase c would be across from angle C. And this is standard. You'll always see this. Of course, you'll see letters besides A, B, and C, but our law of sines is going to use A, B, and C. The law of sines tells us that sine of capital A over A equals sine of capital B over B, which equals sine of capital C over C. And so this is our law of sines right here. We need to make sure we've got this in our notes. Make sure you can find it easily. You might want to label it law of sines. And so the law of sines is really pretty simple to use in the basic cases. However, there are some cases where it becomes a little bit more difficult. So let's talk about that first before we get started using this. The first thing that I want to point out is that if you are given a problem where you know that this angle, let's say, is 50 degrees, this angle is 60 degrees, and you know one of the sides, let's say this side is 7. In this case, you've got two angles and a side. So angle, angle, side. If you remember back in geometry, well, you guys didn't take geometry. You guys had math too. I think this is math too. Whenever you're doing congruent triangles, angle, angle, side is one of the postulates that you can use to prove triangles are congruent. So there is only one triangle that can have these particular measurements. So if you have angle, angle, side, then you're good to go. If you have angle, side, angle, if the side is between the angles, that is also okay, because if you have two of the angles, you could always find the third angle. But if we get into this situation, if we have this side is 9, this side is 15, let's not call it 15, that's not really be off scale, let's call it 10, and this angle right here is 40 degrees. Okay, in this case we have an angle and then two sides. The angle is not between those two sides. And so my angle is not between the sides. This is not side, angle, side, but this is angle side side. And if you remember in Math 2, angle side side, whenever you write that down, you should be alarmed. That does not give us congruent triangles. We cannot have ASS, angle side side. So what that means is there are possibly two triangles that exist with these measurements. Okay, so we can still use the law of signs for this, but what we have to do is we have to watch out for something called the ambiguous case. So we are going to hold off until Monday to look at that because that's a little bit more difficult than what we're going to be looking at today. So just know that whenever you have an angle side side, there's going to be a little something extra that you have to do. However, today we are mostly going to focus on problems that are not angle side to side. So your assignment is going to come from IXL today, and you can see here that I've got a triangle, and in this triangle I'm just going to draw this over here. It is not a right triangle. I've got 45 degrees right here. I've got 49 degrees right here. I don't know W. Let's see, this is Y. This is X. I do know that this side is 14. This side is across from our capital X, so we'll call it X. This side is across from our W, so we'll call it W. And the question asks us to find X. So for this, if I'm looking for X here, then to find X, I'm definitely going to have to use the X across from that. So to start setting up my law of signs, and also notice here I've got two angles and I know a side. So I don't have to worry about finding, I don't have to worry about running into that ambiguous case on this particular problem. So I'm going to have sine of 45 degrees over X. And then that's going to equal, now in our law of signs there were two equal signs. We can't solve an equation whenever we have two equal signs. So what we're doing is we're choosing the two pieces that we need. So if we look over here at our triangle, pick a different color, you can see I know I've got W right here, but the side across from it is W. Well, I don't know either one of those, so that's not going to help me to use those points. Rather, what I need to do is I need to use the Y's because I know both of those numbers. So if I use those Y's, I can set up an equation that I can solve. So sine of 49 degrees is going to go in the top of the fraction, and 14 goes on the bottom. And so this is our equation that we can solve. And if we cross multiply here, we're going to get X times sine of 49 degrees and 14 sine of 45 degrees. And so remember that sine of 49 degrees is a number. So I'm going to pull up Desmos over here so you guys can see what we're doing in the calculator. If I type in sine of 49, I'm getting a negative number, which is a little bit odd. Desmos is going to automatically be in radian mode. We want degrees here because we're using degrees. So if I click on the wrench over here, you can see down here at the bottom, it says radians. I just want to click over here to degrees, and that'll give me a better number for this right here. However, I usually don't change these to decimals yet. I know that what I want to solve for here is this X. So to solve for that x, I need to divide both sides by sine of 49 degrees. And so if I divide both sides by sine of 49 degrees, then I've got x equals all of this stuff right here, and I can just type everything into Desmos at one time. So I'll have 14 sine of 45 over sine of 49. And I'm going to get my answer here, which is 13.117 if I round that to 3 places. Most things that I'm going to give you, I'm going to ask for 3 places. However, in iExcel, they ask for the nearest tenth. So let's just go 13.1 and submit, and you can see that we got that one right. Okay, let's do another problem here. I'm just going to work these from iExcel. So you can see in our picture here, angle X is 112, angle Y is 37. We know the side across from it. They're asking us for the X here. So to set this one up, we could say sine of, we're looking for the X, so we know we need to use 112. Sine of 112 degrees over X equals, and then we're not going to use the Z's because we don't know angle Z and we don't know side Z. Even though we could find angle Z, we don't know side Z, so it wouldn't help us right here. Instead, we want to use 37 and 14, so we'll say sine of 37 degrees over 14. Again, right here, angle, side, we do not have to worry about that ambiguous case, which we'll worry about tomorrow or Monday. So X sine 37 degrees, when we cross multiply, is going to equal 14 sine 112, and then we're going to divide both sides by sine 37. And so whenever we do that, we are going to go to Desmos real quick, and we're going to type in 14 sine 112 over sine 37, and we get 21.569. And so if I type this into iExcel, we're going to round to the tenth, so it's going to be 21.6. And we got another one right. I'm going to skip ahead just a little bit because iExcel will let me do that since mine is a teacher account. And let's look at this problem. So this one is a little bit different. I'm going to copy the problem down, just slightly different. So we've got this triangle here. It's certainly not a right triangle. P, Q, and R. I know this side is P, this side is Q, and this side is 8. My angles here, I've got 125 and 23, and then I don't know angle R. And this question asked me for Q. So Q is the side that I'm looking for right here. That's not an 8. It doesn't look like an 8. It's a Q. So Q right here is what we're looking for. Let's do it like that. So if you notice here, we do have the angle across from Q. So I know I'm going to have sine of 23 degrees over Q. We don't know what Q is. Now, here's our trouble. If I want to set this equal to sine of 125, I don't know P. And you can see I've got two variables here. I can't solve this equation whenever I have two variables, so that's not going to help us very much. But the problem here is I've got this side, 8, I know it, but I don't know the angle across from 8. However, we can find the angle across from 8 really easily because we know that all the angles of a triangle have to add up to 180 degrees. So if we just take 180 and subtract 23 and 125 here, 180 minus, there, 180 minus 125 minus 23. It's going to give us 32. So this is our R. So this angle right here is 32 degrees. So we can find, anytime you have two angles, you can always find that missing angle if you need it. So we're going to have sine of 32 degrees over 8. And so now, let me get this out of the way here. What's that? Put it up here. We're going to cross multiply. And when we cross multiply, we've got Q sine 32 equals 8 sine 23. And we're going to divide both sides by sine 32. And so Q is going to equal, I'm going to type this into Desmos really quickly. We have 8 sine 23 over sine 32, and we're going to get 5.899. 5.899 there, and to type that into Desmos, that's going to round to 5.9. Okay, and I'm going to skip ahead one more time. I don't really think it gives you anything much more difficult than what we just did. So if we look at this problem, it's a little bit similar to what we just found. You can see here that we've got this angle is 36, this angle is 39, we know this side is 23, and then we are looking for V, which is right here. So I know I'm going to have sine 36 over V, but I don't know this angle right here, and I need that angle because it's across from the only side that I know. So again, really easily, we can just do 180 minus 36 minus 39, and if we do that really quickly, 180 minus 36 minus 39 is going to give us 105 for that angle. So to set this up, we're going to have sine of 105 over 23. And like we've done for the others, we're just going to cross multiply here. V sine of 105 equals 23 sine of 36, and we're just going to divide both sides by sine of 105. And so when we do that, we're just going to type that into Desmos. 23 sine 36 over sine 105. It's going to give us 13.995. So V equals 13.99. Actually, it's going to be 996 if we round it to 3 places there. Now, this, we've got to round to the nearest tenth. And so the 9 is going to round that 9 up to a 10, which means we're going to get 14.0 for this. I don't know if you have to put a .0 or not on that, but it'll take it, looks like. So that is the general idea of what you're going to have for your law of sines. So go to IXL. You're going to be in pre-calculus M14 and complete that law of sines assignment for me. You need to get a SMART score of at least 90.